Okay, so this little video is on divisibility tests for a whole bunch of whole numbers, 2, 3, 4, 5, 8, 10, and 11. So basically I'm going to start with just writing all down tests. I'm going to spend some time just showing how they're used, and then we're going to prove some of them. Okay, so this is the divisibility test theorem. Okay, I'm just going to usually say the divisibility test, but it's a big theorem here. A number n is divisible by 2 if its last digit is divisible by 2. Okay, so first of all, what we're going to do, we're going to have a bunch of these just statements all together. So I'm going to just use some number n, and I should really probably say some whole number n, right? Divisible by 2 if its last digit is divisible by 2. Okay, so this is the same as, you know, when we've often said the other alternative is it's 0, 2, 4, 6, or 8. And that's sort of an equivalent way of saying that. 5 if its last digit is 0 or 5. Okay. 10 if its last digit is a 0. Right. 4 if its last 2 digits are divisible by 4, and 8 if its last 3 digits are divisible by 8. Okay, so these first three maybe hopefully are pretty straightforward with that. So the number is divisible by 4 if I just take the last 2 digits and see if it's divisible by 4. So I'll show some examples on that. And then 8, all we're going to do is take the last 3 digits and take a look at this. Okay, so and then I've also got some other ones that I haven't done yet. I've done 3, basically 3 and 11 are a little bit different cases. These, as we will see, are the proofs of them are very similar. I'm going to do a couple of the proofs in here. I think you get to do a few of these. So 5280. So number, let's say test if 5280 is divisible by 2, 4, 5, 10, and 8. Okay. So by 2, yes, because, right, 0 is divisible by 2. So I'm just looking at the last digit. The last digit is 0 is divisible by 2. 0 is divisible by every number. Got that. By 4, yes. Oh, sorry, because 80 is divisible by 4. Right? Pretty straight. Yes, 80 is divisible by 4, so I take the last 2 digits, and I've got that. by 5. Yes, because right, we've got this. Its last digit is 0. 10 is the same, right? So we've got that. Okay. And then 8 by 8. Okay. All right. And this is the last little tricky part here. Are the last 3 digits divisible by 8? Okay. So so one of the things we'll start looking at is we might start doing some mental math to handle some of this stuff. Let me just do a quick little long division. Give me a little bit more room. 280, right, 24405, right, 40, 0, right, and that's key. So yes, because the last 3 digits are also divisible by 8. Okay. So one of the interesting things with this is that, okay, and I picked this, hopefully you recognize this number. That's actually the number of feet in a mile. This is probably one of the reasons for having that relationship between miles and feet, is that you can take a number and divide it into, like, it's divisible by lots of different numbers. So we can easily figure out what a half a mile is, or a tenth of a mile in terms of feet, and all of these things like that, or an eighth of a mile. All of those work nicely with that. Okay, now here's what I'm going to do. I'm going to do a few divisibility tests, proofs. These are all going to be algebraic. Proof of divisibility test by 2. Okay. Unfortunately, I just erased it. But remember, it says that if a whole number n is divisible by 2, if its last digit is divisible by 2. Okay. So we're going to let any number n can be written as this. We're going to see this in a lot of these little proofs. Okay. And basically all you're doing is you're pulls off the last digit and then everything else. Okay, let me just show before we go on with this. All right. So let's say I have, 835, right? Which the last digit is 5, and then 830. Which means I can write this as 83 times 10 plus 5. And there's my A and B. Okay, so we can always do this. This is just a fairly natural thing to do. Okay. Now, here's what we're going to do is I'm going to let A equals 10A. This is divisible by 2 because we can write really write this as 2 times 5a, and because we can write it as 2 times some number, it's divisible by 2. So by the divisibility lemma, n is divisible by 2a. if and only if B is divisible by 2. Right? Okay, so the big thing about this is I've broken this up into two pieces. Right? And we typically, like in the divisibility lemma, we call this guy capital A plus something else is capital B. So I'm just assigning the two pieces to the two big things in the divisibility lemma. Okay. So the first thing is we need to show that one of them, in this case the 10a, is divisible by 2. And then we're going to apply the divisibility lemma. And that again basically just says the whole thing is divisible by 2 if and only if this guy is divisible by 2. It's just like a natural piece of that. Okay. This is like a really sort of example of how we're going to tackle these things. So let me do a couple more of these. Actually, let me just do, I'm going to do one more of these. I'm going to do divisible by 4. So 5, hopefully, maybe you can see 5 and 10 really work very much the same way. You break the number in the same thing and you have to write some stuff down. You'll have some of these in other ways. So proof, so this is going to be proof of divisibility by 4. Okay. N is divisible by 4 if and only if its last 2 digits are divisible by 4. Okay. Ooh, sorry. One of the things, I didn't do this earlier. I like to do a little box, fill in the box when we finish a proof. All right. All right, so let n equal now 100a plus b. So this basically is a way to pull off the last 2 digits of a number, right? And so because I'm going to have 100a, this number is always going to be some multiple of 100, and the rest of it has to be the last 2 digits. Right, so if I did 847 is 8 times 100 plus 47. So my A would be A8 in that case, and B would be 47. All right. A equals 100 times little a. This is divisible by 4 because a equals 4 times 25 little a. So I'm writing it as, I'm taking this and writing it as a multiple of 4. Okay, so this is the, again, the big part of the divisibility lemma. So then again, by the divisibility lemma, n is divisible by 4 if and only if b is divisible by 4. B is the last 2 digits, and B is the last 2 digits of n. And end of proof. Okay, so again, the little thing is, all we're going to do is we're going to split it up into two pieces. The first piece is going to be a multiple of 4. The last piece is going to be whatever's left over. And so all we're going to do is test the last 2 digits. That's this little b here, and we're using the divisibility lemma to basically say that's true. Okay, so that wraps up some divisibility tests for 2. Let's see, and as I'll say, 2. We did 2 and 4. 5 and 10 and 8 work very much the same way. And the next divisibility we're going to talk about 3 and 11.